Hello dear students, in the previous session we had studied the proof of Cauchy's second theorem on limits. In this session, let's solve the problems using Cauchy's second theorem on limits. This is Srimati ASHWINI, Assistant Professor of Mathematics working at SSS GFGC, Moodalgi, Belgavi District. So let's solve the problem. The first problem says, show that the sequence n raised to 1 by n converges to limit L. Limit 1. So let an is equal to n. So if an is equal to n, you know an plus 1 becomes n plus 1. So our next step would be to divide them. That is, an plus 1 by an will be equal to n plus 1 divided by n. When we split the denominator, I would be getting it as 1 plus 1 by n. Next, we would be taking limit n tends to infinity an plus 1 divided by an. That gives us limit n tends to infinity 1 plus 1 by n. We get it as 1 plus 0, that is equal to 1. Now, by Cauchy's second theorem on limits, we know limit n tends to infinity an raised to 1 by n should be equal to the value of limit n tends to infinity an plus 1 by an, and this we have already solved that it is equal to 1. Hence, limit n tends to infinity n raised to 1 by n is equal to 1. Let's solve the next problem. The next problem says, prove that limit n tends to infinity n power n divided by n factorial whole power 1 by n is equal to e. Now this is of the form an to the power of 1 by n. Therefore, an value becomes n raised to n divided by n factorial. Let's find out what is an plus 1. How do we solve this? We replace n by n plus 1. So you get it as n plus 1 raised to n plus 1 divided by n plus 1 factorial. Our next step would be to divide an plus 1 by an. So we have written an plus 1 value as n plus 1 whole raised to n plus 1 divided by n plus 1 into n factorial by n power n. Now, n plus 1 factorial can be written as n plus 1 into n factorial, which on returning can be simplified and n factorial gets cancelled. N plus 1 whole power n plus 1 can be rewritten as n plus 1 whole power n into 1 plus n divided by n plus 1 into n raised to n. So here 1 plus n term gets cancelled. We are left with n plus 1 by n whole power n, which again taking n common in the numerator and denominator, I would be getting an plus 1 by an is equal to 1 plus 1 by n whole power n. Now let's take limit as n tends to infinity. We all know that limit n tends to infinity 1 plus 1 by n whole power n is equal to e. Therefore, by Cauchy's second theorem on limits, our formula is limit n tends to infinity an raised to 1 by n should be equal to the value limit n tends to infinity an plus 1 by an, and we all know that the value of this is equal to e, hence your answer. The next problem is, if xn is equal to 2 power 1 into 3 by 2 square into 4 by 3 cube and so on, when you look into the terms, I can generalize the nth term and write it as n plus 1 by n whole power n to the power of 1 by n. Then show that limit n tends to infinity xn is equal to e. So let's take the given problem as xn, which is already given. Out of this, an is equal to the term which is there in the bracket. So it is 2 by 1 whole power 1 into 3 by 2 whole square into 4 by 3 whole cube and so on, n plus 1 by n whole power n. Now let me find out an plus 1 term, that is till the nth term it is going to be same, and then we are going to add n plus 1 to the given term. So it becomes n plus 2 divided by n plus 1 whole power n plus 1. Now let's divide them. An plus 1 by an is equal to, after dividing, we would be getting it as n plus 2 by n plus 1 to the power of n plus 1. Now this n plus 2 can be written as n plus 1 plus 1. So which on grouping and taking the denominator as a common factor, I would be getting it as 1 plus 1 by n plus 1 to the power of n plus 1. So therefore limit n tends to infinity, an plus 1 by an is equal to limit n tends to infinity 1 plus 1 by n plus 1 whole power n plus 1. And this, when I compare in the problem, the value of this is equal to e. Therefore, by Cauchy's second theorem on limits, we have limit n tends to infinity, an to the power of 1 by n is equal to the value limit n tends to infinity, an plus 1 by an, and this answer is E. So these are the references which I have used. Thank you.